In order to retain knowledge, here I am. Instrumentations and data lecture 1. Okay. So I'll just skip the rest up to here. So I believe that this may be a question in the exam. I don't know. So why do we study electronics instrumentation? So maybe it's like 3 marks. So the first one is actually communication with future engineers, so that you can actually communicate them what are the sensing things that you need, or what is easier for you to know what they are doing, and how can you improve their designs or whatsoever. Second one is system testing, so you can actually test out whether is your system good or whatever. And then the third one is enhance your design, because certainly some robotics or whatever may require a sensing equipment, or maybe your design may require a sensing equipment, but you don't know which sensing equipment to choose. So this actually lists down whatever things that you need. So yeah, and then what can we measure? So there are many parameters like displacement, temperature, heat, etc. So in chapter 3 we'll talk about it, so let's skip it first. So we'll go to terminology. I'll skip this, I'll skip this also, because these are all introductions, and these are all examples telling you that, like, hard drive, this is also taking sensing techniques or whatever, but it's not tested, so it's okay. And then dampers and whatsoever. For this one, it's just you put in some magnetic fouling, and then you let it you let it go. So in a typical situation, you flow through quite well, but under certain circumstances, um, when you press or something, the magnet is on, so you actually causes the magnetic particles to actually um, so-called harden and whatsoever, to restrict the flow of the fluid, so that you can actually break or whatever, to cause to to restrict certain fluid movement. So you actually prevent it can actually cause breaking of like you driving, and then you cause like breaking, whatever. So yeah, this one is the wind turbine, so whatsoever, so I'm not going to talk about it. And then terminology, transducer. So it's a long chunk, so I'll just say it in a way that transducer is to convert one form of energy to another. Okay, one form of energy to another. And then acoustic, chemical, whatever, you can change from one to another. So actuator is to take energy and then you create action. Sensor is to detect, and then combination transducer is to detect and create action, like ultrasonic transducer. So these are the things. Maybe I check it out. And then just to take note, the actuator, you take in mechanical, electrical, and then you change it to a certain other stuffs. Yeah. So an electric motor and a loudspeaker are both actuators. So it converts electrical energy into motion. And then transducer, um, you can both detect and create actions. So it's like yeah, as I say, ultrasonic transducer. If they ask you, you can say that. And then voice coil speaker, you can say that voice coil speaker. It can also add like microphone or whatever. So yeah. And then so what is metrology? I don't know whether, I think you just need to like briefly know. It's just a science of measurement. Okay, embracing both experiment. So you just remember, it's a science of measurement. Is to measure is to measure something. It's the art of measuring. And then what are the purpose? Never mind. You just need to know that it's just for measurement, for metrology. Okay. So is they what their job is to do is actually to 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 ensure SI units are all standardized and whatsoever. Yeah. And then terminology for this is like hold on a while. So accuracy is the degree of closeness of quantity. Precision is the reproducibility and repeatability. So in this case, degree of closeness, as you can see, good accuracy is this one. Okay, this is good accuracy. So you can actually, so a lot of dots are over here. It's hold on a while. So imagine I have a board over here. I have a thing you need to shoot. Okay, this is some guy, and you're gonna shoot him. So if you are high accuracy, maybe perhaps you shoot around this portion, you shoot here, you shoot here, shoot here, right? This is for high accuracy while low precision. Okay, so if it's low precision can be like you shoot a multiple shots, and then it should be like here, multiple shots over here, you know. So this is precision while low accuracy. Okay, so in this case is high precision, low accuracy. For the previous case, okay, if I shoot here, I shoot here, I shoot here, okay, it's good accuracy, high accuracy, but actually low precision. Okay, because they are all scattered around. So if you combine good accuracy and good precision, you have like chunks of us, like headshot. This, yeah, everything is chunked up together like that. So this is high accuracy because you are hitting the target well, and high precision means that you're hitting at a point you are yeah at a point you are actually hitting it in a way. So high precision means that no matter how many times you hit at the same spot. Okay, how many times you hit at the same spot. This is why precision is reproducibility and repeatability, while accuracy is degree of closeness of quantity, meaning um their closeness is not very clear. They are not very close, right? No. They are not accurate. They are fuck. It's a degree of closeness to a given target lah. Okay, so it's a degree of closeness yeah. So it's a degree of closeness to a given target. Okay, you have this given target. How accurate you are from your Okay, I'm gonna skip. Okay, so metrology for engineers. So what is the purpose of this? The purpose of metrology in this case is that you have to ensure that it's so-called what you just need to know interchangeable parts because the same dimensions without meter, without cm, you cannot even know what is the dimension for to create a same dimensions type of thing. So let's say you have a piece of cylinder and then you have 5 cm now. So if you want to change this part, you also need 5 cm, right? You need to have a certain metric, meaning some ruler to measure 5 cm, and then you create a cylinder that has a diameter of 5 cm also. So this methodology is important for interchangeable parts, so that you can actually change whatever parts that you want easily. Then the other one is actually the other purpose is actually to because with this SI unit you can actually form another. You just need to know exchange of engineering data. Okay, so you need to understand interchangeable parts and exchange of engineering data. This meaning is based on let's say Newton per meter. Newton meter, okay, Newton meter can be re-represented by another form. Like Newton can be re-represented by joules per meter, I think. Whatever lah. Okay, so you can see that without this SI unit you cannot have the changing of SI units. Maybe hold. Let's say you have a rho GH over here, and but you are given only mass and a certain volume. What you can do is actually to sub in rho equals to m over v, and then you can actually calculate and solve for that. So without metrology, you cannot even have this type of calculation, converting from one parameter to another parameters. So these are all the stuff that he's trying to talk about. So you just remember interchangeable parts and exchange of engineering data. That's all. And then what? So the SI units, there are actually 7 type of SI unit. That is the basis. That means the primary SI unit. The secondary SI units are like maybe Newton meter or whatever. So maybe I should show you one. So the standard set of SI unit is actually this one, which corresponds to what you've seen here. Okay, which they are the same. Okay, I didn't cheat a feeling. They are the same. But so these are the primary units. So I would believe that in the test they may actually ask you to what is the fundamental units of electronics. So maybe you can say ampere, but not voltage. Voltage is simply in terms of ampere, I think, I don't know, whatever. But for electric current, ampere is the fundamental unit, meaning the primary units. For the derived units, as you can see, is meter per second square. It's all like mixed up, like are the combinations of these ones. So the derived units are the combinations of all these things, and a lot of combinations. Yeah, whatsoever. Yeah, I don't know what I'm talking, but yeah, you should know that this is the things. Okay, it's a good concept. And then what do we have? So in this module, you're gonna learn a lot of stuff. You for chapter three you learn about sensors. Chapter 4 you learn about what's that called, AC. Then chapter 5 you're gonna learn filter, amplifier, and etc. So these are the four key things. Okay, electronic circuit, principle of sensor, filter assumptions, ADC and DAC, meaning analog to digital or digital to analog. Okay, so these are the things I think chapter 2 will talk about for this one. Filter assumption, chapter 5 and the rest. Then chapter 3 and then hopefully, yeah. So see you in the next video for chapter 2. So I've already cleared for chapter 1. These are the key points that I mentioned are all inside here. So I'll see you in the next video. Bye bye.